ideal gas goes through a cycle consisting of isothermal, polytropic, and adiabatic life, with the isothermal process proceeding at the maximum temperature of the whole cycle. Find the efficiency of such a cycle if the absolute temperature varies and falls within the cycle. The situation is shown in the figure. Process 1 to 2 adiabatic, process 2 to 3 isothermal, and process 3 to 1 polytropic expansion. Now, according to question, the isothermal process proceeds at maximum temperature, hence T2 T3 will be maximum. Now, T2 by T1 equals to N, hence the total work done will be dW equals to P1 V1 minus P2 V2 divided by gamma minus 1 plus P2 V2 log V3 by V2 plus P3 V3 minus P1 V1 by N minus 1, where N index of expansion of polytropic process. Now, it is clear that the heat will be also added during polytropic process. Seen in adiabatic process, dq equals to 0, hence dq equals to Cv into T1 minus T3 plus P3 V3 minus P1 V1 by N minus 1. For polytropic process 3 to 1, P3 V3 to the power N equals to P1 V1 to the power N, or R T3 into V3 to the power N by V3 into R equals to R T1 by V1 into V1 to the power N. This implies T3 by T1 equals to V1 by V2 to the power N minus 1. Also during process 1 to 2 adiabatic, also during process 1 to 2 adiabatic, P1 V1 to the power gamma equals to P2 V2 to the power gamma. This implies T2 by T1 equals to under bracket V1 by V2 to the power gamma minus 1, equation 4. Hence efficiency eta equals to dW by dq. Also T2 equals to NT1. Using the above 6 equation and rearranging them, from which we get efficiency eta equals to 1 minus N minus 1 by N log N. Answer. An ideal gas with the adiabatic exponent gamma goes through a direct clockwise cycle consisting of adiabatic, isobaric, and isochoric lines. Find the efficiency of the cycle if in the adiabatic process the volume of the ideal gas A increases and falls, B decreases and falls. As in the graph shown, process 1 to 2 isochoric, process 3 to 1 isobaric, and process 2 to 3 adiabatic, all are shown in the clockwise direction. It is clear that the work done will be only during adiabatic and isobaric process. From graph, it is also clear that the pressure of point 2 is more and hence temperature, hence the heat is added during process 1 to 2 isochloric. Now given V3 by V2 equals to N, work done dW equals to P2 V2 minus P3 V3 by gamma minus 1 plus P3 into V1 minus V3, equation 1, and heat added Cv T2 minus T1. Now efficiency eta equals to dW by dq equals to P2 V2 minus P3 V3 into gamma minus 1 plus P3 V1 minus V3 by Cv T2 minus T1 equals to R into T2 minus T3 by gamma minus 1 plus R into T1 minus 3 divided by CV into T2 minus T1 equals to T2 minus T3 by T1 minus T3 plus R by CV T1 minus 3 by T2 minus T1. Now P2 V2 to the power gamma equals to P3 V2 to the power gamma. This implies T1 by T3 equals to V3 by V1 to the power gamma minus 1. Equation 4. Also V1 equals to V2 and T1 equals to T3. Again P1 by T1 equals to P2 by T2 and V1 by T1 equals to V3 by T3. Using the above 6 equation we get eta equals to 1 minus gamma into n minus 1 by n to the power gamma minus 1. B. Since the volumes decreases n-fold, V1 by n equals to V2. This implies V1 by V2 equals to n. dW work done equals to P1 V1 minus P2 V2 by gamma minus 1 plus P2 into V3 minus V2. V3 equals to V1 and P2 equals to P3. Again P3 by T3 equals to P1 by T1 and V2 by T2 equals to V3 by T3. Also T1 by T2 another at V2 by V1 to the power gamma minus 1. Question 5. It is clear that the maximum temperature will be for either points 4 or 3. Hence the addition of heat is during the adiabatic process. dq equals to P1 V1 minus P2 V2 to the power gamma divided by gamma minus 1 plus Cv into T2 minus 3. Using these 6 equations, we can get it at dW by dq equals to 1 minus n to the power gamma minus 1 divided by gamma into n minus 1 into n to the power gamma minus 1. Sir.